Okay, so my name's Stephen Roth, as I mentioned, and I'm the president of CarmelSoft, and we develop mobile apps for the HVAC industry, and we also do a lot of consulting for various HVAC manufacturers, developing customized software for them, including equipment selection software. Also, we've developed a web-based tool for ASHRAE, for their ASHRAE Building EQ, building rating system, and lots of other related type software. So today I will be demoing the HVAC ResLoad-J app, which works on your iPad. And the purpose of this app is to conduct peak cooling and heating loads for residential and light commercial facilities. And it is based upon ACCA Manual J8, and it is approved by ACCA. And it's been approved by ACCA since almost 2012 now, so almost 6.5, 7 years. So it's a very popular app used by thousands of people throughout the world, and we periodically like to give demos just to, show people how to use it and also get feedback on ways that we can improve this app. So as I mentioned before, feel free at any time to ask a question, and if you do want to verbally ask it, just make sure you unmute yourself. Also, you can ask it in the little chat window in your GoToMeeting applet, and I will look at those and try to answer those questions. So let's get started. So what you see on your screen here is what's called an emulator, and it allows us to do demos of our app. And I'm actually demoing this on my MacBook, not on my iPad. So this is my MacBook running an emulator of the HVAC ResLoad-J app. And the nice thing about it is it allows us to test the software and also do demos like this. And I'm going to be demoing in landscape mode. So this is the mode you see it in right now, landscape mode. And you can also use it in portrait mode, and it looks a little different. The inputs are laid out a little differently, but all the inputs are the same. They're just laid out differently to accommodate your portrait mode. But I'm going to demo it in landscape. It's just a more user-friendly mode in my eyes. All right, so here what you see is kind of the startup screen when you first start the app. And on the left here is a list of all your projects. And then on the right is a list of the inputs. And this is a common theme throughout the app, is you all have a list of either all your projects or all your envelopes or windows or skylights, and then on the right will be all of your inputs. And on the left here, you can select a project, and the inputs for that project will appear. You can also add new projects, so click the plus button. And what you can do is you can actually copy a project to a new project, so you don't have to re-enter all that data again. So that's a nice thing if you have a house that's similar to a previous house you did and you don't want to re-enter all the window and wall data. You can copy that and then just change it for the new project. Or you just create a brand new project. And when a brand new project is created, it's actually based upon this default project. So make sure not to delete this. Some people actually delete it, and it kind of causes the app to go a little nuts. So don't delete this default app, because this is the basis for any new projects that you create that you don't copy. And then also a lot of people, we get a lot of calls for this one. How do I delete a project? Well, all you need to do is swipe with your finger, and you'll see the little delete button. Click delete, and it will delete your project. So it's amazing how many phone calls we get for that one. And that's, once again, a common theme throughout the app. Anytime there's like an envelope, you want to delete that, you just swipe it. Let's see, for some reason it's not doing it there. Should be. Not sure why. Maybe because there's just one. I think there has to at least be one. That's probably it. Oh yeah, because it's default. Sorry about that. So if we go to envelope and swipe, there you go. Delete. Yeah, like I said, the default one you shouldn't mess with. All right. So just for the sake of time, I'm not going to create a brand new project. I'm going to demo an existing project, just because doing a brand new project would take up way too much time, and I really want to concentrate on explaining a lot of the inputs and also getting feedback from you and also questions from you about any specific items that you want to see. All right, so I'm going to demo the Ross Resonance, and like I said, on the right are the inputs all associated with this Ross Resonance project. Now you may be asking yourself, now what is a project exactly? Well, it depends. If you have a normal size house, you pretty much want to have a project for that house. However, if you have a really large house which has multiple systems, you may actually want to have separate projects for each system in that house. So for example, you would name it Ross Residence System 1, Ross Residence System 2. So a project can either be an entire house or it can be a system within a house, especially if you have a large house which has multiple systems. All right, so in this case, we're just going to deal with one system, one house. Ross Residence. Now on the right here, as I mentioned, are all the inputs, and you can access additional inputs by swiping with your finger, and you see additional inputs here, and then swipe again, and here you see some results. So let's go back. And once again, for the sake of time, I am not going to explain every single input because it would take hours to do that. So I'm going to highlight, the inputs that either require the most explanation or maybe ones that aren't so obvious, or ones that we've gotten a lot of questions about over the years. All right, so this section allows you to enter all your demographic information, nothing too onerous here. The only thing that I do want to show you is the city input. So if you click this little caret there, it's going to pop up a form that allows you to select your city. And why you want to do that is you want to be able to get that weather data. Now your exact city may not be in this list, probably won't be because there's about 1,000 cities, but it's worldwide. So you'll want to select the city that is most closest to the city that where you're located or where your house is being modeled. And you can always click the map it button. I'm not going to click it just because we're not on Wi-Fi here, because this is an emulator. But if you click map it, it will actually display a Google map or an Apple map, and then it will kind of show you it will show you your city, and then if there's any cities within that are located close to your city, so you can select that one. So that's kind of convenient. All right, so once you select the city, you can always change the name here, but it will keep the data that you selected here. So that's the most important thing. You can also override this data if you go inside it. And let me actually go display. Bear with me while I display the keyboard. Toggle keyboard. There we go. All right, so you can actually go in here and type another value. Suppose I want it to be 89 degrees instead of 91. I can do that. And what it will do is it will override it for this specific project, but it won't override it the next time you do another project and you select the same city. So for this specific project, you can override that weather data if you want. And once again, this is a common theme. You can enter information just by, putting your finger inside the text box. Your keyboard will pop up, and then you can enter the value. All right, so let's move on. Down here is where you enter your square footage that are cooled, that is heated, and an average height. Now, one thing I do want to show you is, you can always put your finger inside it and type in a number. And once again, let me pop up this keyboard. But sometimes you'll see a little slider control. And the nice thing about this is you can move that slider and you'll see it'll increase, decrease that value. And the nice thing about that is as you're increasing and decreasing it, it's actually updating your load dynamically. So you can actually see how it changes your load. So that's the nice thing about these sliders, if you're not too concerned about exact numbers. Now, I'm going to delete this number here. Let's see here. Let me go back. Not sure why that keyboard doesn't keep popping up. Oh, I think I know why. I keep hitting that bottom button. So I'm just going to click done. There we go. All right. So now you see a maroon number. And what that means, any maroon number you see anywhere in the program means it's a derived number. So in this case, as I move the slider control for my cooling, it's also going to move the slider for my heating, because most of the time you're going to cool and heat the same square area, square footage of your home. So this is what that maroon number means, that it's derived from another input. However, I can always override. So in this case, if I move the slider for my heating, you'll see now it's overridden and it's moving on its own. So in other words, the two are not coordinated or in sync anymore. So, but if you want to go back to it being derived from the cooling, just erase the number and it will be maroon again. And that, like I said, that's a common theme. We'll see this in other inputs in the app. Here you would enter your average room height. So really the goal here is we want to get the volume of our home because we want to be able to calculate proper infiltration, excuse me, and ventilation and other information. So it's important that we get the volume of our home. So even if you have different heights throughout your house, try to get an average value so we get the volume of that home. Number of bedrooms, and then you'll see this is a maroon number for the number of occupants. So the number of bedrooms is just, the number of occupants is actually equal to the number of bedrooms plus 1. All right, appliance loads. So, especially these days, people have multiple TVs in their home and Xboxes and computers and, lots of devices that are giving off lots of heat. So now, especially, these days it's important to really make sure you enter all of these heat producing devices. So if you want to be lazy about it and just say, oh, I think it's adding about 1200 BTU per hour, you can do that, or medium 24 or high 34, or you can customize this list. So I customize, click the little caret there. I can actually start adding items to my appliance list and also specifying the BTU per hour that each of those give off. So here we have a dishwasher. Okay, we have one. This is pre-filled. So dishwasher gives it off around 4,000 BTU per hour sensible, about 1,400 latent, and percent hour used. I mean, it's not used 100% of the time, obviously, but so you want to enter a percentage that you think your dishwasher is contributing load to your home. And it will do the math, and this is the sensible and latent load that is being accounted for in your home for a dishwasher. Here, a color television. Here we can enter a quantity of 4. Once again, enter your sensible load. How much do you watch TV? 10%, that may be low. Maybe some people have the TV on 100%, so you'd want to enter 100%. Then you can add additional items. So here I have a whole list of items I can add. Here, computer. Let's select that. Everyone has computers, and a lot of homes have multiple computers now. So let's enter a quantity of, say, 4 computers. Multiply 4 times my sensible of 1,500. Percent used, let's reduce that to, say, 50%. And then here's my total sensible load due to my computers. And I can keep adding more and more appliance items as I go. And what happens is when I click done, you'll see my total appliance load now is 2,700 BTU per hour, and that's added into my internal load here. And you'll see when we do the room by room later that you'll be able to assign individual appliances to your individual rooms. And then while I'm talking about, let's talk about this up here. So currently we're in what's called the block load mode. So we do things a little differently than maybe some of the other load calc tools out there because we're assuming you're taking this iPad, you're going to be out in the field doing this, you're going to be at the house doing your load. And most people, they want to be able to size equipment pretty quickly. So we start out by allowing you to model the home as a whole block, as one big block, okay? And then if you want to get more granular or get more detailed and start sizing each of the rooms, like, ductwork for each room, airflow if you want to know the loads, then you do the room by room. But you don't have to do the room by room. You can just do a block load and size your equipment and you're done. But if you want to get more detailed, you can do room by room. Now this is actually the opposite of what some desktop software tools do, where they start with the room by room and it builds up to the block load. Because we're assuming you're out in the field, you want to do something quick because you want to size that equipment. So we start with the block load. But the nice thing about this is you can use information that you've entered in the block load in your room by room. So it's not like you're re-entering information all over again. And I'll show you that in a bit. All right, so with that explained, let me talk about this little pie chart here. So as you saw, when I was changing information here, changing inputs, my loads were changing. So this is a breakdown of my total cooling load. And then if I click heating, this is a breakdown of my heating load. And once again, I can, as I'm changing my floor area, it's changing my heating load. Then I have what's called an Aed curve. Now there's nothing here because it's a little bit more intensive calc, so I have to click the little calculator icon up here. And now what this has done, this has actually mapped my cooling load by hour from 8 a.m. to 8 p.m. So you'll see throughout the day, my cooling load is increasing, which is pretty typical because, by noon, 1 o'clock, the sun is, high in the sky. It's contributing a fair amount of solar load. So your cooling load requirements are greatest in the early to mid-afternoon, depending upon the orientation of your home. And then as the afternoon wears on and night comes, obviously the sun goes down, not as much solar load, and there's less cooling load requirements. So this is kind of a load profile, a cooling load profile of your home throughout the day. And this is actually a requirement to get ACCA approved, is we do need to show this Aed curve. Now, you'll see two lines here. If this peak of this curve goes above this yellow line, what that means is you're not adequately diversified in your home. So that means you probably need some type of VAV system. Okay, if you're at or below this line, top line, then you're okay with a constant volume system. So in this case, we're okay. But if this had gone above the line, then it suggested that you get a variable air volume system, because there's so much diversity in your home that in the morning, the west side of your home may be overcooled if you have this constant volume system. Meanwhile, in the evening, toward the late afternoon, the east side of your home may be overcooled because, as you know, the sun rises in the east and sets in the west. So it's important maybe to have a VAV system for that home. So that's what this curve means. And this curve also will be drawn for each of the rooms too, and I'll show you that in a bit. All right, let's move on. So we got a lot to cover here. So like I said, I'm not going to go through every single input here, just the ones that where we've gotten the most support calls for. Before I continue, though, are there any questions at all? And if you do have a question, make sure you unmute yourself and ask it, and remute. Okay. If not, I will continue. So I've swiped to the second screen from my project view, and here I can enter my cooling and heating set point and also relative humidity. And once again, as I move my slider control here, look how it's affecting my cooling load. And then if I select heating, and if I move my heating set point slider, you see how it's affecting my heating load. So pretty interesting stuff there. All right, let's move down to additional inputs. Construction tightness. Is your home new? Is it old? Is it, really old? Well, if it's brand new, most likely it's going to have a tight construction. If it's, maybe 10, 15, 20 years old, maybe an average construction. And if we're talking 30, 40 years old and has not been renovated, a more loose construction. And what this is used for is your infiltration calcs. So it's important that you, select the option that most approximates what type of home you have. All right, so infiltration. So if for those of you who don't know, infiltration is basically air that is leaking into the home. And I'm not talking about ventilation air that's coming in through your furnace. I'm talking about air that's leaking through your, leaky windows, or your door that doesn't have weather strip, or even your chimney. That air is not conditioned, obviously, because it's leaking in. Ventilation air is conditioned, so that's different. But infiltration air is not conditioned. So we need to account for that, especially in the winter. If you have high winds, cold air leaking through your home, you need to offset that load, obviously, by heating it more. So ACCA has 3 different methods of infiltration, calculating infiltration: the Manual J air change method, the blower door method, and the direct entry method. I'm going to talk about the first method. The second method is actually quite complicated, probably not worth talking about in this webinar right now. Direct entry method is actually really simple. It just asks you, enter the number of air changes per hour, and automatically calculates the CFM. Real simple. But the Manual J air change method requires a couple different inputs, and it will calculate the number of air changes for you. So first you tell it how many exposures and how many stories is my home. And then based upon the tightness that I selected before, it will calculate the number of air changes per hour, and then based upon the volume of your home, it will calculate the total CFM of infiltration. And then click done, and you'll see here's my let's go here. Actually, oh, there's no infiltration. I think the reason there's no infiltration is because I have ventilation. And what's happening is because I have outside air coming in through my furnace, it's actually causing a positive pressure. As a result, there will be no infiltration. But if I did have infiltration, it would fill it out here. So the nice thing about this program is it does kind of take into account your ventilation, your exhaust, and your infiltration. And it will determine whether there's positive or negative pressure in your home. And if there is positive pressure in your home, then you will have no infiltration. If there's negative pressure in your home, that means there will be infiltration. But in terms of heating, it looks like there is some infiltration because if we look at the heating here, our infiltration load is actually much greater. If you notice, for our cooling is much less, right? It was 75, but for in heating in winter or heating season, our infiltration is much greater. So it's actually greater than the ventilation CFM. So as a result, we do have an infiltration load in the wintertime. And you'll notice for the winter that there's 2 additional inputs, and that is related to your fireplace. Because what happens is in the winter, especially if your flue is open, you may have some air leaking in through your chimney stack and coming into your room. So it's important to take that into account. And you also need to take into account the tightness of your fireplace construction. So you can see for heating, we indeed do have infiltration. So we get lots of questions about this. If you do have more questions later on, I'll be giving you my contact information at the end of this webinar, and you'll be able to call me or email me about that. All right, so ventilation rate. As I mentioned, we do account for ventilation. Now, ventilation is outside air coming in through your furnace, so it is going to be conditioned, whether it's in the winter or summer. And you can either brute force enter a ventilation rate, CFM value, in this case we enter 94, or you can have the program automatically calculate it for you, and it's calculated once again based upon a bunch of different factors. Okay, so brute force enter it or have it calculate. Here you can enter exhaust, so if you have bathroom exhaust that's running fairly often, you can enter that, and once again that will be coordinated with your infiltration and ventilation to determine whether you have a positive or negative pressure in that home, and it will calculate everything accordingly. All right, let's talk about duct. So this is not a Manual D program. We don't have a Manual D program out yet. We are developing one, but it is not out yet, and that requires a whole nother approval process by ACCA to get Manual D approved. However, as part of the Manual J calcs, we do need to account for any heat loss or heat gain in the ductwork. So what we allow you to do is model your duct system, in an approximate way. So let's look at what we've done here. So here we have a supply, and we can also model our return if we have a return. So a supply duct, we can specify a bunch of parameters for our supply duct and then enter the approximate surface area of our supply duct, and it will calculate our duct load, meaning the amount of leakage of air coming out of that duct, and as a result, what do we need to compensate for that, whether it's cooling or heating. So here, duct location, is it in a crawl space, an attic, unconditioned basement? Duct system type, is it a radial with outlet or trunk and branch? Duct configuration, single, 2-story. Duct R value. The higher the R value, the higher the insulation. Duct leakage, is it really sealed and tested? That means it's good new construction, or is it totally leaking unsealed? If it's unsealed, obviously there's going to be a lot greater load contribution to the ductwork. I usually, if you're unsure, just say average. The floor area, this is automatically calculated, or this was entered by you previously, and the duct surface area is actually just 18% of the floor area, and that's what the ACCA Manual J8 handbook suggests. You can override this. See how this is maroon? So it's calculated. You can always override this. So if you go in here, you can change that if you know the duct surface area. Now, based upon all that, if I go out, click done, you're going to see that my duct heat loss is, wow, almost 3 tons. So this is why it's important to really get this duct parameters correct, because duct heat loss can contribute a lot to your load. In this case, I think it's too high. So let's go back in here real quick. And let's change it back to a sealed and tested. And you'll see now, because there'll be a lot less leakage, now it's down to about 2 tons, which is still pretty significant. So just make sure you pay attention to this. All right. So are there any questions about some of these inputs? Because as I mentioned, we get a lot of calls about these, and I just want to make sure I answer these questions for you while we're online here. Sure. When you say default, what default are you talking about exactly? Oh, this guy. Oh, yeah, I see what you're saying. You could do that, or what I would really do instead of messing with his default is I would create, I would create a project called template and enter all the information that you want, and then from that point on, when you want to create a new project, you would just say click copy from existing, you would select template and create your new project, and it would have all those values that you entered in your template. That's what I would do. Yeah, no problem. All right, so let's continue. So I'm going to swipe, and here you see a detailed breakdown of both the cooling and heating load, and also the percentages of each. And this screen actually exists on a bunch of different tabs here. So this kind of gives you a real quick, detailed view of your loads. And once again, we get a lot of calls saying, hey, my load doesn't look right. And I'm thinking, okay, there could be a million different reasons why your load doesn't look right. So what I always tell the person is make sure you look at your breakdown and what value in your breakdown looks way out of whack. And a lot of times people will say, oh yeah, my window load looks really high. And then they'll see that, hey, you know what, the type of window they selected was, way too old, or, a single pane window with a really, really high U value or low R value. And as a result, their window load was way out of whack. So this really helps inform you if you do have a load that just does not look correct. Make sure you look at the breakdown and see which value does not look correct in your breakdown, and that will help you diagnose what's going on here. Then you can go correct it. All right, so let's move on. So we've talked about our project inputs. Now we're going to go to our envelope. So envelope includes wall, roof, floor, door, anything that's opaque or anything that's non-fenestration or non-glass. And what you do here is on the left here, you add in all of those envelope items. Similar to what we did for project, you can add in your envelope items here. You click the plus button. You can always copy from an existing. So if you have a wall that's similar, on the east as the west wall, you can always copy your west wall to your east wall and then just, redo a couple of the characteristics. So, same kind of theme here. You can all add new ones or copy from existing. And as I select each different envelope item, you see on the right there, the inputs update accordingly. And like I said, you can always delete if you swipe. All right, so let's look at west wall. All right, so on the right here are my inputs associated with my west wall. So I want this to be a wall. So in this case, I'm going to select, above grade wall. An envelope, as I mentioned, could be a door, a wall, a basement wall, a partition wall, which is a wall inside your home but is adjacent to, say, a garage or some other unconditioned space, a ceiling or floor. Once again, a ceiling could be a roof. A partition ceiling could be a ceiling that's below your attic, which is not conditioned. So above grade wall, and then I need to select the orientation of that wall. Then I'm going to select the construction number. So this, the ACCA Manual J handbook and also this app includes literally hundreds of different construction types for walls, roofs, floors, doors. So all those construction types are in this app. And this form shows you all the construction types. They're categorized by frame wall, block wall, or alternative. So in this case, I selected a frame wall, and I selected this number actually comes from the ACCA Manual J8 handbook, and this is a wood frame brick veneer R0. So let's change this to an R11, okay? And then what it does is it automatically fills in my U value here, and also my CLTD group, which is most of the time you're not going to touch this, but it's related to the solar characteristics of that wall. Now, if you happen to know that your wall is an exact U value, which is obviously 1 over the R value, you can go in here and edit it. Same with your CLTD group. And then you can enter your wall width and wall height, and it will multiply these two values together to get your area, and it will calculate your total wall load for both summer and winter time. So let's look at south wall. And actually this should say south, so I'm going to select that. This is the construction type. And these are the dimensions, the wall width and height. East wall, let me change that to east, and then north wall. There we go. All right, so let's look at in Vended Attic. So here we have a ceiling partition, or I'm sorry, a ceiling envelope, and this actually represents the roof. Okay, so ceiling in this case is a roof. We want to know the orientation of it if it's slanted or sloped. So it's sloped to the northeast. Here, once again, we have 3 categories of roof, whether it's under attic, roof deck, or a roof joist. So I'm going to select roof deck, the 17A4, which is a 0.134 U value. It fills that value in, which I can always override. Then I can enter the ceiling or the roof length, roof width, and the slope of that roof. So this is the load contribution due to my roof into my home. Almost a ton, a little over a ton for cooling, 33,000 BTU per hour for heating. Partition wall, as I mentioned, is an indoor wall, but it's a wall that's adjacent to an unconditioned space. So once again, I have my 3 categories of wall that I can select from. Fills in my U value and my CLTD group, which in this case is irrelevant because we're not worried about solar load for partition walls. You enter the wall width and height, but you also enter the temperature on the other side of that wall. Say it's in my garage, I would enter this cooling temperature during the summer and the heating temperature during winter. So that's my partition wall. So another question we get a lot is, do I need to model those walls that are between my living room and my dining room or between my 2 bedrooms? No, you do not. Because those walls, there's no heat coming across those walls because the conditions, the set point on each of the side of those walls is the same. So you can ignore those walls. You don't have to model every single wall in your home. Only walls which are either facing outside or walls that are adjacent to an unconditioned space. Any other walls you can totally ignore. We literally get that question probably once every couple weeks. And it makes your life much easier if you do not have to enter all of the areas of all the walls in that home. Because you don't have to. You can ignore them. All right, so that's envelope. And you can see here, once again, you have your pie chart that you can view. And you also have that detailed breakdown, which we saw before. All right, let's move on to window. Same thing. On the left, I have a list of all my windows. I can add additional windows. I can copy from existing windows, and I can also delete windows. On the right are all my inputs associated with my windows. So you'll see there's a lot more inputs associated with my windows than my envelope, mainly because of shading. So I'm going to select a west-facing window. And the reason it's west-facing is because I am actually attaching that window to my west wall. So if you remember in my envelope here, I created a west wall. Well, now that west wall is listed here. I'm attaching that window to the west wall. So that's doing 2 things. One, it's assigning the west orientation, which I selected here, to that wall, to that window, which is obviously very important because of fenestration or solar load. I mean, if we have a window that's facing north, the solar load won't be as great as a window that's facing southwest. So we need to know the orientation of that window and wall. And the other reason it's important that we're assigning that window to that wall is we're actually subtracting out the area of our window from that wall. So it will calculate it correctly. Construction number, here I can select from single, double, or triple pane walls. And it will automatically fill in, actually before I do that, frame construction, is it a wood, metal, insulated fiberglass frame? Then based upon these combination of inputs, it will auto fill in my U value and my solar heat gain coefficient value. As you can see, these are maroon, so these are derived. You can always override them. So if you see the sticker on your new Anderson or Milgard windows, and it shows you either an R or U value or an SHGC value, you can enter those values in here. What type of window is it? Default, bay, or garden? And if I have, say, 5 of the exact same window, the exact same area, you can enter the area of one of those windows and then just enter a quantity. All this does is multiplies this number by that number to get the total area of window. South-facing window, once again, I assign my window to my south wall, enter the characteristics of it, and so on. So let's talk about shading. So a big part of windows, obviously, is shading. And that really can affect your solar load considerably, the different types of shading. So here, our first section here talks about internal shading. Internal shading can either be blinds, roller shade, drapes, and what percentage of the window are my blinds shading. You can also select whether there's an insect screen, internal or external. Down here we can select what's called a sunscreen. What type of sunscreen is it? And what percentage of the window is the sunscreen covering? And then on the right here we can specify any exterior shading. So first is what's our ground reflectance? Like if we're surrounded by concrete, it's going to probably reflect a lot more sunlight onto our building than if we're surrounded by green grass. Then you can select overhang. So if you have overhangs above your windows, you can specify the window height, the overhang length, and the distance above the window that the overhang is, and it does all the geometry and it will calculate how much that overhang is shading your window, and it will consider that portion of the window that's shaded. It will just take into account the heat, the heat transfer as opposed to the fenestration, because the sun is not shining on that part of the window. So you can take into account both internal and external shading for your windows. All right, so as you can see, there's a lot more windows here. You can add as many as you want. And why don't we move on? Skylights. Skylights are obviously just windows on your roof, right? So once again, you can add as many skylights as you want. You can copy skylights. You can delete skylights. And then you can assign your skylight to your roof or a ceiling that you defined in your envelope. So in this case, I defined this F ceiling here. So if I go here, and you'll see that the ceiling is listed here. I assigned it to there. It does a couple things. Once again, it subtracts out the area of my skylight from that roof or ceiling, and it also takes into account the slope and the direction it's facing. I can select a construction type for that, the glass of my skylight. What type of curb construction? It will auto fill in my U value and my solar heat gain coefficient, which I can override if I want. I can enter the area of my skylight. How many do I have? Calculates the total area and then does my cooling and heating load. Okay, so yeah, so that's the basics for project, envelope, window, and skylight. So before we move on to room by room, let's talk a little bit about reporting. So here you'll see a little pie chart icon. If I click that, up pops up a menu option that allows me to display different types of reports. So let's look at the system reports first. So the system reports pop up, and I can swipe, and you'll see there's different types of reports here. There's kind of an overview report. There's a checksum report, which does lots of rule of thumb values. There's a breakdown report with a breakdown of all my loads for cooling and heating and also percentages. There's a room by room report, which we'll look at in a bit. And finally, there's my pie chart report. Now, what's nice about this is if you click the envelope icon here, which I'm not going to do because I'm not on a real iPad, but just on my emulator, it will actually send an email with the PDF of the report that you see on your screen. So you can email these reports to yourself. And room reports, let me show you that in a bit after we do the room by room. An HTML report, that will open up your email client and it will insert an HTML report in it, a breakdown of both the inputs and outputs, and also a spreadsheet. So that's a convenient report. If you want to be able to email yourself a spreadsheet and then customize that report, you can do that. And this final option, email database, this is more for kind of helping us detect issues. Like, so for example, if someone's having an issue or they have questions about a project, they can actually email us their database and we can open up on our iPad and find out what the issue is. And this actually has proven to be helpful. Also, email database, if you have multiple users in your company and you want to be able to transfer your projects to them, you can do that too. So that's what email database means. All right, before we move on, let's talk about the eye icon. Eye icon is kind of just settings or preferences for the app. So, you know, you can select either English or metric units. 99% of the people using this are in the US, but we do have some people in Mexico or even Canada and Quebec using this app, so they'll be using metric units. Down here you can select, we get a lot of confusion with this. Some people think that this is the floor area of the house that you're actually, you know, working on, but no, this is actually just the max value on your slider control. So you see 10,000 here. If I go back to my project, you'll see 10,000 is on my slider. That in no way affects your current job in terms of what the area of your home is. The area of your home is what you enter here, not in the I button up here. This is just the max for your slider. And also, as you move your slider, you can either move one at a time or you can move step 5 or 10 or whatever. And these are max value for other types of sliders. So you can kind of customize the app if you want. You can enter your company information here, so that's printed on the reports. Then help, so you click this and it will go to the help page. And it's pretty detailed help and includes written help and also videos. All right, before I move on to the room by room, are there any questions about the block load section that I've talked about for the past 50 or so minutes? Sure. Yeah. I'm surprised there'd be software out there that would not ask for that, because I mean that's the basics for calculating a load contribution to a roof. So yes, you do need to enter that. I mean, does it have to be 100% accurate? No, because truthfully, the roof contributions to your total load are not as great as other contributions like windows. I mean, not by and far, windows is what really contributes to your cooling load. Roof and wall, especially these days in new homes, is far less. So if you're a little off in your area, it's not going to affect your load too much. But yeah, you do need to input that. That's pretty basic. That's pretty basic information there. Yeah, no problem. Okay, so we have about 10 minutes or so left, and so I do want to explain the room by room mode. So as I mentioned, you know, when you first start a project, you really need to enter all your information in the block load mode. Once you get to the room by room, now you can start entering information about the individual rooms if you're in your home. Now you don't have to do this, but only do this if you're going to be sizing ductwork for your individual rooms, or if you just want to happen to know the load for certain rooms. Now, you'll see here in this mode, you can actually start entering individual rooms. And once again, same concept as the block load. You have your rooms here. You can click plus. You can copy from existing rooms. So if you have 3 bedrooms that are exactly the same, you can copy those, or you can create new rooms. And then on the right are your inputs associated with that room. And within each room, once again, you have an envelope, window, and skylight. So let's talk about our office first. So on the right here, we can actually assign, if you remember under the block load, we did those appliances when we added a dishwasher, television, and computer. Well, now we can start assigning those appliances to individual rooms. So in this case, I can assign, let's assign a color television. Let's assign one of them to my room. Click appliance, click done. Now it's going to add that in right here. Okay. Then I can also enter the number of occupants in that room, since the person will contribute some cool, sensible and latent load. Under the envelope. So now what we try to do here to make it easier is, you've already entered all your envelopes in the block load. So what we do is you can assign the type of envelope that you entered in your block load to your room. So in this case, let's look at the north wall. All right, so I have a north wall here, and here's a list of all of the walls that I defined under my block load. I'm going to select the north wall that I defined in my block load, and now I'm going to enter the area of that north wall for my block load, but only the area that is part of this room, which is my office. So in other words, if I go back to north wall here, you'll see I have an area of 370 square feet. Okay. If I go to room by room, what I can say is, of that 370 square feet, 220 square feet of that is part of my office. So you can enter that. And then, if you have another room, say I have a bedroom that also has a north wall. Let's see, bathroom. I may not be able to find it, but yeah, suppose I had a bedroom that was also had a north wall. I can enter an additional square footage. Now you can always go greater than the square footage you enter on your block load. So in this case, we have 370 square feet. If you happen to go 480 square feet, between the two rooms, it's not going to ding you for that. You can do that. But it does show you how much remaining area there is. So it does give you a reference. But that's nice. Some people complain, well, do I need to enter my information twice if I want to do room by room and block? No. What you're doing is you're taking the information you entered in your block load and you're assigning it to the room by room. So same with my south wall. I select south wall, which came from my block load, and I enter the area of that south wall that is part of my bedroom 1 here. And then here's my pie chart with my cooling, heating, and here you're going to see Aed curves for individual rooms. So here I have a load profile where it peaks around 4 or 5 p.m. Let's go to my office. Similar to that, let's look at another. Oh yeah, check this out. See how that load profile is a little different? It peaks more toward the morning or early afternoon. So really depending upon where the windows are. If the windows are facing the east, you're going to get a higher load in the morning. If the windows are facing west, you're going to get a higher load in the afternoon. So this shows you your cooling load. So kind of interesting. All right, so envelope, same thing with windows. I start adding windows. I can assign the windows that I created in my block load to this particular room, my office, and then I take the area of the window that is part of this office and enter it, and it assigns that load to this room. And finally, same thing with skylight. In this case, there's no skylight in my office. Let's go to kitchen. Probably, yeah, nothing in the kitchen. I'm not sure if I assigned one, but you can assign the skylight. So the room by room should go fairly quickly because you've already entered all your information on a block load. You just need to assign it to the different rooms in your home. Now the one, we get calls about this all the time too. It's like, how come the total of my room loads is not equal to my block load? Well, I'd be more worried if they were equal, because they will never be equal. If they are, it's a total coincidence. The reason they will never be equal is your room loads are going to peak, your cooling room loads are going to peak at different times of the day. So the total of your room loads is going to be greater than your block load, because your block load obviously only peaks one time a day. So your block load may peak at, say, 2 p.m. Meanwhile, one room may peak at 3 p.m. Another room may peak at 11 a.m. So obviously at those different times, there's different loads for that room. So when you add up all your room loads, it's going to usually be greater than your block load. It will never be equal. If it is, it's a total coincidence. So we get that question all the time, and it should be that way. I mean, that's the way it is, because your rooms peak at different times of the day. If we go into the reports here, room report, you'll see I can select my office. Here's my breakdown of my pie chart breakdown, including my Aed curve. And actually, if I go to my cistern report, I can also see a condensed breakdown of my rooms here. So here are my room cooling, room heating, and my airflows. And this is what people really like, are the airflow values, because then they can size their ductwork. All right. And so that's pretty much an overview of the app itself. One other feature of the app, which is a whole nother webinar, is our equipment locator. And I'm not going to show it now, but basically what it is it allows you, if you're a technician or a contractor out in the field and you want to keep track of all your equipment that you're maintaining, you can do that through this app. It's called the Locator. Store it in the cloud, share it with other users in your company, and it is part of this app, and it's actually part of every single app we have out there. So just to let you know about it. All right, so that is pretty much an overview of this app. And are there any questions that you want to ask me before I end the webinar? Last chance. Any questions? Okay, well, if you do happen to remember that you had a question after the fact, feel free to email or call me. Our 800 number is on the website, carmelsoft.com. Also, my email, just email me at info, I-N-F-O, at carmelsoft.com, and I'll respond to that. Also, you may want to check back on the website. We'll be posting a recording of this video probably within the week. And so you'll be able to kind of review and refresh your memory on certain items. But last chance for any questions. If there are no questions, I will end this webinar, and I do thank you all very much for attending, and have a great rest of your day.